So today, what I'm going to talk about is primarily rust and some fungicides for maybe non-rust, non-disease benefits. And so basically, I'm pretty concerned about rust. We saw a ton of it in the last 2 years, late in the season in 2023, a little earlier in the season in 2024. And it can be an economic problem, but we've got really good tools for it. So I'm going to focus on that initially. And then I've had many, many questions over the years about fungicides and do they have an impact when there's low or no disease? What's it do after a hail? What's an application do after hail? And does it matter if there's a disease like rust and hail all together? And so we're going to try to answer some of those questions. And some of the information is actually really good, and I want to put it in front of you so you can maybe consider this when you're making management decisions on diseases throughout the season. I will mention I'm not going to cover today a few things that are important. So sclerotinia head rot, we've talked a lot about in the last few years. It needs a cool and wet, and we have very few tools for it. Fungicides don't work well. Phomopsis, Phomopsis stem canker can be a big problem. It's dependent on rain and storms, and we do have some fungicides that can help. We've also got some better genetics, and so there's things happening there that we want to consider if we have this cool, wet, rainy season. Downy mildew, many of you remember downy mildew. We survey for this, we've been looking for this. It is very limited in recent years. And this is excellent because we've got great tools. It's part of the reason we have few downy mildew samples is weather, right? It needs a cool and wet as well, rain after planting. But we've got really good genetic resistance, and we've got a rock star seed treatment in oxythiopypirolin, which is sold as Lumicina or Planaris, depending on the company you're using. But for today, I'm going to focus on rust and some of the fungicide effects we've been taking a look at. Okay, with sunflower rust, a reminder of a few things. It's a fungal pathogen, and it's very specific to sunflower. So lots of different crops have a rust. There's leaf rust on wheat, there's dry bean rust, that sort of thing. Rust typically have like one host. So sunflower rust is not going to go to dry bean, it's not going to go to wheat. Wheat rust is not going to go to sunflower, but they generally like the same conditions. So when you see rust show up, you often see multiple rusts. So just keep in mind, sunflower rust is very specific to sunflower. This one's a little different than some of the other rusts. It overwinters in North Dakota. It overwinters in cold climates. So it doesn't have to blow up from the south like some of the wheat rust we're used to. It likes it wet and it likes it warm. And in that environment, it can be really explosive. It can move from being just a few pustules to an epidemic in a matter of weeks. The good news here is that we can manage rust. We've got some genetics for resistance that are good, and fungicides are very good. We've worked out some of those details. So we'll show you rust here. So rust is it's a really kind of complex but interesting life cycle. There's 5 spore stages, which is really unusual for most pathogens. In the case of sunflower rust, we see 2 types of spores, 2 types of pustules at the end of the season. This kind of cinnamon brown, dusty spore called Eurydice that we see everywhere, and then Telia, which at the end of the season, they turn black. And this is important because that's how they overwinter. So they overwinter as this Telia. And early in the season, you might see these 2 early spore stages develop. They're orange, they don't look rusty, they're little orange cups and things. But if we see this, we know we're going to have a rust issue in the year. So we've seen some of these things. Now, this is a really close-up image of a sunflower volunteer with rust on the cotyledon itself. And so when you see rust really early, you're pretty much going to have a rust problem. On the upper side of the leaf, you'll often see like a little bump, little orange bump, and I've got a quarter on the screen just for size reference, maybe at the most an eraser on a pencil. And if you flip a leaf over on the other side, you're going to see little orange cups, and you will need like a hand lens to see this, but this is the first stage of rust. From there, you see these cinnamon brown pustules, and this is what we really care about because these repeat over and over and over and over again. And this is the spore stage. These are the structures that create the epidemic. Now, all rusts really need frequent leaf wetness, and sunflower is no different. So if you see an environment where you have fog or long dews, you're going to probably get rust if you've got anywhere in the area, in the field. And so this is a leaf that I'm holding up as an example of how this works. So this leaf I found in a field, and it was horizontal to the ground with a little divot in the middle of the leaf, a little depression. And that depression was enough to collect dew long enough that there was a rust epidemic just in that depression. So an emphasis that rust doesn't need rain, it needs leaf wetness, dew, fog, that sort of thing. All right, when you get rust going, it can really cause problems. And so this is what rust can do in an epidemic year. And I took these pictures a few years ago, but we did see some of this year. And in really severe epidemics at the end of the season, you can see rust cover up the stem, the petioles, the bracts. It can do a lot of damage. Now, you don't always get rust, and rust is unpredictable, and there's other things that can influence whether you get rust, like genetics for resistance. But in this year particular, I think we need to really pay attention to it. Okay, and this is why. So in 2023 and 24, the NSA, the National Sunflower Association, funded a PhD student, Zach Ittle. And so Zach Ittle works with me, and he's got a couple years left. And Zach led an effort to try to figure out how much rust we've got. And he's doing some other projects with rust too, but I'm presenting some of his survey work. And so he and Dennis Colombo, who's a researcher in our department as well, went out surveying. And then we got some really good help from the NSA board members who would bring Zach to the farm and he'd be able to survey specific fields in specific areas. And we got some samples from our private sector partners and some of our cooperators too. So over the 2 years, Zach, Dennis, or some of our cooperators sent us over 80 samples in North Dakota. Here's a map. You can see the color differences of the 2 years. The white is 23, the green is 24. Zach was going all over the place. This is South Dakota. In South Dakota, they focused primarily in the center corridor, although they took a sample from the northeast corner of the state. Got some samples from Nebraska. So this is a map of Nebraska with an inset. So the sunflowers are primarily grown on the western side of the state. So there's 10 samples, 10 fields from that area as well. A little bit in Minnesota, primarily in the northeast. And then we went and got some survey work done in Wisconsin too. So not really fields here necessarily, but rust was all over the volunteers, the road ditches, things like that. All right. So what Zach and Dennis and others found is that in all these areas they surveyed in 2023, so both Dakotas, Wisconsin, Nebraska, Minnesota, they found rust in 65 out of 67 fields. He was surveying in August, and that's a big difference than the end of the season, late September or October. 2024, they found it in every single field or location they stopped. That is a lot of rust. That's 122 out of 124 fields. 98% of everywhere they looked for rust, they found it. So no matter where you're growing sunflowers this year, there's probably going to be rust around. It's probably going to overwinter. It's probably going to show up in the growing season, and it's something we need to watch. So it's been everywhere recently. All right, so how do we manage this? So the first thing is destroy the volunteers. Like if you have an old farmstead with a whole bunch of wild sunflowers, it really is in your best interest to get rid of them because rust will survive there and other problems as well, other diseases as well. Hybrid selection is really important. So we do tend to see confections being more susceptible than oils, but the companies are pretty good about moving resistance genes into the material, into the hybrids that you grow. Just keep in mind that rust forms races, and so often the resistance genes don't last forever. This is one of the things Zach is looking at is how good are our genes right now. And then fungicides, which I'm going to spend the rest of the time on. So fungicides are excellent if you need them. Now, not everyone needs a fungicide. Rust doesn't show up everywhere every year. So scouting becomes really important. The timing for this is about 0.5% to 1% severity on the top leaves at or before R5. And I'm going to show you what this looks like. And then you have lots of products to choose from. We have a lot of fungicides that are pretty effective, and we're going to go through some of those. So the first thing I'm showing you here is a severity scale that we use for rust trials. It goes from basically a trace, so 0.1% up in the upper left corner, all the way to about 40% of the leaf area covered in the lower right. At this point, the leaves are completely wilted and done. So when we're talking about a threshold, we're really looking at this area. So if you're starting to bloom and you've got this level of rust on the upper leaves, a fungicide application is probably going to be economically viable for you. It's something you really should consider. In some of our trials, it's even less than this. Rust doesn't need a lot on the leaf to trip a fungicide application. And that's because it can be so explosive. It can increase so rapidly. All right, so In the real world, this is about what 1% severity looks like. So this is an upper leaf, a big, nice, big, healthy leaf with some pustules kind of around the edges, right? At this point, you probably want to spray. All right, again, that severity threshold is 1% severity, upper four leaves, at or before R5 bloom, and maybe even less. We've seen positive impacts with a trace of rust. Okay, to give you an example of some of the things that we've looked at, one of the students funded by the NSA a few years back did a really good, robust study on sunflower rust and confections. Okay, and what you're looking at here is you've got disease severity on the bottom. So this goes from 0 to 6%. Now, 6% doesn't sound like a lot, but keep in mind those severity diagrams. 5 to 10% is actually quite a bit. Okay, so this is the disease severity, and this is at right after he applied a fungicide. Okay, so this is just getting into R6, late R5. And what we're seeing at that point, so the time he put the fungicide down, was the non-treated control had only 0.5% severity of rust. Really not much, but it's on the upper leaves, and we know it can be explosive. And then he tested multiple fungicides. So here you have some triazoles, so these are most generic, tebuconazole, really inexpensive. He took some strobilurins. How did they perform? Took some SDHIs, actually Vertisan, so same group as Endura, and then had some mixed products. So he had all kinds of different products ranging in price from being very inexpensive to being very expensive. Okay, so this is what it looked like at R6. By R7, rust had exploded. And so you see severity exceeding 6% on the non-treated. And that is going from here to about here in just a few weeks. And that's a huge jump. Okay, the fungicides, though, really beat it down. So the triazoles worked really well, the strobilurins worked really well. SDHI, the one product we tested, also worked really well, although at a higher rate. And then the combo products all worked really well. At the end of the day, a lot of these chemicals work pretty well on rust. So we couldn't get yield from every trial, but we combined the yields from the ones we could, and there was a strong yield benefit, even at that 6% severity. So here's the yield in the non-treated control, 2350 maybe, right? And I should mention that all the letters behind the bars are the statistical differences. So if you don't see the same letter, they are different. And you can see that there was a yield bump in pretty much all the products that managed rust the best, ranging from maybe 2 to 500. So rust, even at that level of severity, can cause some pretty significant yield loss. Keeping in mind this is confections, just in general. All right. Last year, we did a really small study just to check out a few things, and we anticipated that we'd have high rust pressure, and in fact, we did. And so you can see the non-treated here at R7 when we rated this was at 20%. It was just like a burn down. And even with the single application at that highest severity, if done at R5, really knocked that rust pressure down. And so here we're taking just pretty straightforward products. There's generics out there, some of these, and that application at R5 made a huge difference. Unfortunately, we lost the trial and couldn't get the yield, but I can almost guarantee you the yield was dramatically different. Okay, just keeping in mind that was 20%. That's what that non-treated looked like in our trial last year. Okay, so fungicides and rust, just to summarize quickly. The first thing is that it's going to become important to scout this year. Actually looking for rust is important. And I would suggest that you start when you get close to the canopy closure. I might suggest you start close to a shelter belt if you have one, because you get longer dew periods often, or maybe fog or less wind. All of those contribute to higher leaf wetness, and that's what rust really needs. Target that 0.5% to 1% severity on the upper leaves at R5. And there's lots of products available. There's lots of good products available. Our work over the years kind of points to triazoles, strobilurins, but some of the SDHIs can be effective as well. Lots of combination products. You got a lot to choose from. Okay, fungicides in general. So a few things. The North Dakota Specialty Crop Block Grant and the National Sunflower Association supported this project in the last couple of years. My hat's off to the North Dakota Specialty Crop Block Grant program for looking at this. This was very helpful. And of course, the NSA is super supportive. The objective of this, objectives, I should say, is do fungicides impact yield and how, and what environment, and does it matter if there's hail, and does it matter if there's disease? So we were looking at multiple components. And what I'm going to present to you primarily today is non or low disease environments with and without rust, and I'll explain why. Okay, I'm going to show you a few slides like this. I don't want you to get lost in the details. I am putting a whole bunch of information on the side of the screen, not for you to read now, but maybe later if you're curious and coming back. It should explain pretty well what we did. Okay, so walking you through what we did here in this first experiment, the objective here of this first one was to test products in a hail-stressed environment in the absence of disease. So what happens if hail comes in and there's really no disease? Does a fungicide work? Okay. Well, unfortunately, we couldn't really test this because we got natural hail in addition to our synthetic hail. And then when we looked at it all together, there was no difference whether there was hail or not hail. The results told us a different story, unrelated to hail. So what we ended up doing is we started to combine the data from all these non-diseased or low disease environments. And that's what I'm presenting. One important thing I will mention is that fungicides in this experiment were applied a couple days after we put down our synthetic hail. Okay, that was the objective. Natural hail kind of messed that up. It didn't really matter in the end, but all the chemicals are put down at R2. R2 is not optimal for rust. We talked about R5 for rust. R2 can have an effect on other things like phomopsis and phoma, maybe low-level septoria. So there's other diseases here, but what I'm presenting here is a very low disease environment. So just keep that in mind. Okay, I'm going to throw you 4 bars up here, and the bigger the bar, the more the yield. I'm going to point out right away that the pounds per acre here is really high. These are really high disease environments, and this was all done on confection or yield environments, high yield environments. It was all done on confection, so just a little caveat on what's going on here. And the 4 bars I'm going to throw at you are a non-treated. So what was the yield of a non-treated? Priaxor. So Priaxor was selected because it has headline in it. And headline was really the first product that started talking about a non-disease environment yield benefit or plant health, right? So we took that particular chemical and used that as our baseline just because it was early in the marketplace many years ago. There are other products that have this sort of labeling now, but that's why we selected Priaxor. Badge is a copper product. We selected this to look at because copper products tend to have an effect on bacteria. And when you have hail, you open wounds in the leaf and bacteria can set in. So we wanted to try to negate that effect, right? And then we put a Priaxor and badge treatment combined. So what we saw in the non-treated control was about 3,200 pounds an acre. Really, really high yield environment. We saw a numerical increase with all the other treatments, particularly with Priaxor and Priaxor plus badge. This was not statistically different though, and I'm going to say that with a little asterisk. So when we look at things for statistical differences, we use a value that tells us are we 95% confident that there's a difference? And the answer here is no, we're not 95% confident. But we are 88% confident there's a difference. So you can take statistics and you can have a level of integrity in the data anywhere. I think it's important for me to show you this, even though I'm not 95% confident, with a p of 0.05, it's pretty close. It is really pretty close, and there's a lot of data that went into this. Okay, the next thing I'm going to show you is kind of the worst case scenario for a sunflower. So you've got rust in a trial, and then you've got rust, then you've got hail. And so do you put in a fungicide to try to deal with the hail, even with or without rust? But in this case, we added the rust to this. And again, same sort of setup here. They're all applied at R2. Okay. Now I'm going to show you a couple different things. The first is I'm going to show you a series of blue bars that are yield. Okay, so the blue bars are yield. Bigger the bar, higher the yield, very high yield environment. The red bars are severity. So this is rust severity. Okay, same kind of thing as last time, but now we've got some rust. Keeping in mind that rust is really pretty low. Okay, it's really 3%. That could do a little damage, but it's not like 20% or 7%. and the other ones I showed you when we talked about rust. Okay, so rust first, severity first. So we've got the non-treated control. There's about 1.5% rust in the non-treated. Praxer, Luna experience and onset all knocked it down. And we selected Praxer for the same reason I just mentioned. We selected Luna experience because it's a different combination product. And then onset because it's an inexpensive tebuconazole that we know works well on rust. So knocked rust down a little bit. The yield was impressive though. So you have this non-treated control at 2750, and then you have some statistical differentiation with some of these fungicides. I mean, it's 200-300 pounds, and it's not directly related to the rust, right? So the best rust control didn't necessarily have the best yield impact. So there's something going on here. We saw the same thing in 2023. Okay, so just wrapping this up here, a few things. We had a very high yield environment. That is a caveat that everyone needs to know, and it was confectionery. We couldn't test the hail effect alone, but what we did see is that fungicides, and in our case, Praxer, just because that's the one we tested, did impact yield, or the impact on yield in a non-disease environment wasn't statistically better, but it was consistently close. And then when we looked at a little bit of rust, we did see statistical increases. And maybe it's that the rust was just enough to push it over the statistical mark, but they basically kind of tell the same story. Something's going on at R2. And I will say very clearly that many other things, FOMA, Phomopsis, Septoria, Alternaria, these little nickel and dime ones can come in at that time. And that may be the effect as well. Okay, so take home messages. Keep an eye out for rust. Fungicides do work really well, target that 0.5%, 1% severity. And then I presented a bunch of stuff that I've not presented really before just because it's so new about rust and hail and non-disease environments. Okay, remember there's a few others I didn't cover important, and a big thank you to all the people that helped us with this. And there's more resources at sunflowernsa.com. There's a whole disease section that we just updated with pages of 18 diseases. So if you need more disease help, there's a good place to go. Thank you very much.